Let me check. Someone said, what about the slide? Do you still need the slide? I already shared the video with us. I mean, everything you need is in the video, and it's not a serious slide as the case may be. I'm not really much of a writing person. I just teach, and then you practice. So, all right. Good evening once again. I share my screen.
Good evening, sir.
I believe we can all see my screen.
Not yet.
I can see it from my hand. I don't know why we can see
Yes,
it.
we can see it now, sir.
So okay, the types of variables
Yes.
in research and statistics are, well, you must have read at some point in time, and then you must have seen different types, must have seen different ways by which people put their variables and all. But variables practically, or let me start from even data. You know, they have that name the different types or sources of data. We have practically, primary data, and then we have a secondary data. The primary data is the data that is, you collect yourself primarily, as the word primary implies, a data you are collecting or you are getting yourself. Why secondary data is the data that is readily available. But one thing about secondary data is it was previously primary before it became secondary data. So most times, how do you get a primary data? You tend to collect them in terms of questionnaire, interviews, could be a telephone interview, could be a one-on-one interview. And how do you get the secondary data? Most times you get secondary data from different sites, NCDC sites, and different repositories, maybe even from the registers in the hospitals. And then most of the data collected in the register, first primary data, because someone is taking it. And then when another person goes into the hospital or the company, as the case may be, such a data becomes a primary data. So that is that on that. So let's just go to the types of variables in research and statistics. Practically, variables are classified based on their nature and role in analysis. Below are the main types. If you are talking about the measurements, we have the qualitative and the quantitative. You know, at times people say that, oh, what type of study are you doing? You hear the word of like, oh, I'm doing a qualitative study, I'm doing a quantitative study, or I'm doing a qualitative research, or I'm doing a quantitative research. So same also we have our qualitative variables, which practically we call a categorical variable. A categorical variable. Nominal, and their types is nominal, no meaningful order, such as gender. You have male, female, and then maybe in some countries we have a different gender apart from male and female, but practically, as to the best of my knowledge, you have male and female. We have different types of blood type, A, B, and O. The marital status is in the sense that is this person married or not married. And then we have the ordinal variables. It has a meaningful order, but no fixed interval. Example is your educational level, satisfaction scale, whether you are satisfied or you are not satisfied. Then we have the quantitative, which is numerical. From the word quantitative, it can be quantified. Simple. Quantitative is in numerical values. Most times, qualitative cannot be quantified. Not most times, it can be quantified, but quantitative can be quantified. And we have the discrete and the continuous variables. The discrete is countable, it's a whole number. The number of children you have given birth to, maybe the number of wives you have, if at all such an individual, I know it's a polygamous family. The number of days or the number of times you visited the hospital based on appointments. And then we have the continuous variable. From the word continuous, it is continuous. It is not countable in the real sense. It is not whole number. If you check, for instance, if you check your weight can either be 69.5, your weight could be 69.8, your weight could be 70.1. But the number of children you have cannot be 1.2. Is it possible you have a children that is 1.2? No. So that shows the number of children is a discrete variable. It is countable, it's a whole number. Your number of hospital visits cannot be 1.9. Did you visit the hospital 1.5 in a day? No. See that you visited the hospital once or twice. Why blood pressure too? It is a continuous, and the same thing as temperature. So, and then based on role in research, variables can be put in such like, we have an independent variable. What is an independent variable? An independent variable is the variable that influences or predicts changes in another variable. Such a variable is independent. It is not dependent on any. It influences or changes in another variable. In some part, some call it predictor on exposure, especially if it's medical line or the public health, they call it on the predictor exposure. And some call it explanatory variables. It depends on the department or the field at which you are using it. Why the dependent variable? Okay, an example has been cited. One, a dependent variable is also called an outcome variable, a response variable. So the variable affected by changes in the independent variable, the blood pressure in a study. So, well, this is confounding variable and extraneous factor that influences both the independent and dependent variable. For instance, age can be a confounding variable. And then there are some variables you control for. When we go further, you will understand these things better, especially when we are doing a regression analysis. But this is just more like, something to expose us to what we will be doing. By the time we begin to do a regression analysis, you understand what we mean by, controlling a variable or holding a variable constant. When we have so many independent variables, you begin to hold some constant or you begin to control for those variables. Then based on the data collection, as I mentioned, you have the primary and then the secondary. Primary is the one directly collected for the study, and second is the one obtained from existing data sources. This is just an introduction before we go into the practical session, because I could see that last week some of us perhaps were not so sure of the type of variables we were dealing with. And I really appreciate it if you can quickly open the data set I sent earlier. That data was extracted from one of the data I've worked on in the past. I hope you can still see my screen. So this time around,
yes,
we'll be playing
Yes, we
around
can
our
see it.
SPSS. Thank you. We're playing around SPSS a lot. What I mean by playing around, we'll be doing some transformations. What some persons call is maybe like a recategorization. Let's say, for instance, now, let's click on this education. What do we have there? You could see that we have the primary, secondary, and the tertiary education. What this speaks to is that this is cholesterol, triglyceride, and then the HDL. Those of us in the medical fields, we understand better. I'm thinking if we can have BMI. What do you think? Should we add BMI to this? Are we together?
what's the meaning BMI?
Oh, okay.
Body mass index.
Okay, I was about to ask. Okay, BMI is body mass index, as the person rightly said. And then for you to get BMI, there are some other recategorizations that you might have to do. But most times, when you collect a primary data, you have the height and the weight. And most times, some of these things have been done already. I really wish I can lay my hands on the data that will speak to it so that we can then recategorize based on that. But well, in the absence of one, maybe before the next class, I'll try and get one, or I'll just play around, something quite all right, and then maybe in the course of our practice, or yeah, let me put it that way, we can play around it ourselves. So we have age. This is the serial number, if I'm correct. We have age, we have sex, we have education, this is the marital status. Let me rename it, or okay, it's already in the value label. It's already in the label, rather. This is the marital status. And then we have the level or grade in appointment, and then the number of years the person has spent in service. Okay, the social demographic characteristics are not really there. What I mean by the social demographic characteristics is the age, sex. We have some of it, education. The ethnic group is not there anyways. Okay, have a chat. Oh, sorry. Someone said I'm fast. All right. Someone said he or she can't hear. Can we all hear me now?
Yes.
Yes, we can hear you. We can hear you.
I guess basically have to check this or our network.
Loud and clear.
All right, thank you. Okay, now, practically, if you notice last class, I mentioned that when please don't write on the screen. Thank you. This decimals has an influence or whatever data you have. If you notice, these ones have 000, while this has the two decimal places. This also has to the two decimal places. What kind of variable do you think this is? This is practically a continuous variable. And then if you click on this cholesterol, you will notice that it has 0.40, 3.80. It's in two decimal places as we can see from the variable view. Now, let me just see how we can play around it. Let's try from some transformation. Now, one thing is certain about your variable. Let's say, for instance, the sex we have is male and female. See, for instance, this is the age we have. This age is a continuous variable as well, 30, 36, 23, and so on. Let's say, for instance, I want to put it into categories. Let me say, I'm not sure of the lowest age. Okay, I think we have from 20. Okay, the lowest age around is maybe, let's say, 20. Let's just assume, which is not. Let's say I want to put it into categories of 20 to 30. Let's say I want to do 31 to 40. Are we with me? Let's say I want to do 41 to 50. And then maybe, let me just do 50 and above. What I just need to do is just click transform. Now, one thing about here is that either recode into same variables or you recode into different variables. Now, I will tell us the difference between the two. If you recode age into same variable, what will happen is when you are done recoding, the new variable automatically takes over the previous variable and then you lose that data. So I always advise recode into different variables so that you can still have the original data. Then you can still have the new data. So what I would do is that I will recode into different variables. So what do I want to record? I want to record age. I click. What's the name I want to call it? Let me say recorded age. Then let me just copy and paste this. Control C. Control V. Let me just space. Set change automatically. This is now you come here, old and new values. Old and new values means old is the previous value you have and new values is the new value you are having. You click here. Now value, you have system missing, range and all. Well, I'm much more interested in range. So I'll click range. I'll start from the lowest. Say you have different range. You can start from lowest true value. You can start from range value to highest. Now I want to specify the range I'm interested in. Let's say the lowest age is 20. Let me say I'm interested in 20 to 30 years of age. Then I'll come here. What value do I want to assign to it? I want to assign 0. So I'll just add. I have 20 through 30. I've assigned 0. I'm still trying the same format. Let me say I want to do 31 to 40, depending on the type of study you are doing or the kind of analysis you're interested in. Let me put 1 here. So I had. Let me say I want to do 41. Okay, 41 to 50. Then this will be 2. Then I had. Now, let me say I'm interested in range value to highest. I'll just put range. Click on range value to highest. I'll just click 51. What? 51 rather. What this implies is that it will pick 8 from 51 to the highest. Range value through highest. It starts from 51 to the highest. So I'll just click, let me say I put 3. It's possible that there may not be any value under it. So I'll click continue, change, and I click OK. You have the output. This is the syntax I was telling us about in the last class. This is the syntax. What the syntax is trying to tell you is that warning what you have, and then this is the command, save output, record age. It's telling us that I recorded 20 through 30 and I represented as 0. I recorded from 31 to 40, I represented as 1. I recorded from 41 to 50, represented as 2. And then from 51 to the highest. Let me just close this. If you come towards this side, you can see that we have age recorded. Now it's still showing decimal. So let me change that here. So let me put it as 0 so that you can have the, let me just come back here. So we have, you can see 1 0 0 0 0 Those are the values. Okay, I have 3. So let me go back. You will need to assign the values, as I said in the last class. So we had from I think we had 0, and then that was 20 to 30 years. Is that correct? Hello, do you see you people
Yeah.
online?
Yes, sir.
Yes.
Okay.
Yes.
Then we
yes.
have 1. That's 31 to 40 years, isn't it? You had, don't forget. Then we have 2, which is 41 to 50 years, right? Am I correct? Then we have the last one, which is 3, which is 51 years and above. Am I communicating? 51
Yes,
years and
sir.
above. So you click OK. Oh, my bad. I didn't press add. Don't forget you had, then you click OK. Then automatically you can come here. You have it settled. If you want to just do an analysis now, it will represent all those value labels which you have, or the values which you have already. One thing is germane also. Let's say I want to do a descriptive statistics. See, did you notice what I did? I selected that variable alone and I did a descriptive statistics on it. Did you see what it did? Can you see the output? I will show us that again. You can select a single variable. Then you click. What do? Descriptive statistics. What you're trying to do is that you can just do a descriptive statistics to just see or explore how your variable looks like. And then you can also sort here. You can sort your number in ascending or a descending order. You can even edit the variable name. You can copy with the variable names, copy with the value label, and paste elsewhere. And then you can copy and paste elsewhere. These are some of the things you can do. You can even insert variable. If I click insert variable, it will shift this. Have you noticed that I shifted it? And then I have another one. So I've just done an exploratory analysis there to see how our age will look like. Let me try and then still recode the age again. I can still transform it as much as I want. Transform. Now let's try recode into same variable and you see what will happen. Or what do you think? Shouldn't we try it? Let's try it and see what will happen.
Let's try
Yes,
it.
sir.
See, if you notice, when I did for recode into different variable, it brought out the new name or the name I want to give the variable, and then the label I want to give to it. Did you notice that? I want a response, please.
Yes. Yes.
But in this case, it's still retaining the same name. What I would just need to do is just to specify what I intend to do. What the system is missing is it takes care of missing variables. Is that okay? If there are missing variables, it takes care of it. Now, let me say I'm interested in this range again. Or if it's just a value, if let's say it's just 1 I'm interested in, I'll just add 1. Then 1 to the value I'm interested in. But in this case, it's range. Let's do range through lowest true value. What that means is that I'll start from 0 to 20 here. Let me just say 0 to 30. So the value is 0. Let me add. So what you do is the lowest true, which means that from the lowest number, the other time we did 20 to 30. This means it will take care of any value that is lower than 30 downward. So the second one, let's do range. I'm trying different approaches so that you understand. True. Oh, sorry. This will be 31 to 40. Still the same thing. Then you add 1. Add. Let's say we have let's cut it a little bit here. Let's say we have from 41 through the highest. I omitted. Sorry. You notice it didn't save 41. Then you add 2. Add. Then you put OK. Then you click OK. If you notice, see, it says recode age. Now let's do a descriptive analysis on the age. If you notice, no new variable was created. It has recorded into the same variable. What did I say? It has recorded into the same variable. No new variable was created. So let's come here. Let's click on age. Let's do a descriptive analysis. You see what you have. See age, mean, okay, lowest. It's showing us the lowest. I'm coming. What something? Okay. I didn't remember to specify the value label or the label of the value. That's why we have this error. Let me do that. Okay, the values have been assigned here, but they have not been assigned here. So we did I think 0, and that means 20 to 30. Am I correct? Add.
No.
Okay, what did we use, please? Hello, what did we use? Someone
I
said
think
no.
it's
Less than
21.
less
to
than
30.
30. Less than 30.
It's
Less
less than
than
30. When we check, okay, I just wanted to confuse one, but it shows we are following, but at the same time, I think we are here to really get it right. Now, if you noticed the other time, when I did for the recorded age, I checked through, or let me say I glanced through my data, I noticed that no value is less than 20 there, isn't it? Hello,
Yes,
house, isn't it?
yes,
So, and I
yes.
started from 20. So if less than 30, 20 to 30 is still the same thing. Okay, what I could have just done, let me just say, I can just say, okay, 0 to 30. It's still the same thing because the lowest age there is not even up to 20. Is that faking? For the sake of clarity, you can just use 20 to 30. I just decided to, in a way, try something new. Is that okay? So change. So another one, let's say 31 to 40, add. Then 2. I did 41 years and above, right? Yes. So you had, then okay. The value label has been created. So let's do this. Let's do a descriptive statistics. Something is wrong somewhere. Is either I didn't specify correctly. 0 and 1, 0 and 1, 0 and 1, 2, age. Okay, let me come here, analyze. Let me see what is wrong. We must have made a mistake somewhere. Descriptive statistics, frequencies. Let me select the age. Aha, this is it. Have you seen it? Have you seen it?
Yes.
Yes, we can
What
see
I
it.
think happened there is SPSS is still seeing that age as a previous age because that one does not have categories. So, but now this time around, I decided to use the real analyze button. Analyze, descriptive statistics, frequencies, click your age. Now let's pick this age and then the recorded age two together. See what you have. Okay, see the first one. That one had up to, okay, different one. Now let's check something. Let's say, for instance, cholesterol. Let's go online a little. Because in analysis too, you will do a lot of research as the case may be. Let's check how is cholesterol categorized. You can say measured or categorized. You will see different stuffs online. Okay, here is saying low density group. Let's see. I just hope we are able to get one quickly. Okay. We've seen a study. Cholesterol says, okay, I'm coming. That's one beauty of analysis. You will do a lot of research when you're trying to analyze data, or at times when you're trying to clean your data. This one says less than 25 with lower. The estimate is okay. Or do we have a med lab scientist on the call? Okay, okay, great. Fasting triglyceride, HDL, LD triglyceride, schizemia. Low risk, less than 5%. One thing I know is, for instance, that there's a benchmark for categorizing all of this. It's just like we have, okay, let me use, since this is going to take much of our time, let's check how BMI is categorized. How is BMI? I hope I will be able to categorize. Okay, now it says underweight less than 18.5, normal weight 18.5 to 24.9, overweight 25 to 29.9, then obese 30 or greater. I really wish I can quickly get how cholesterol is categorized, but let's check again. One minute. Okay, someone dropped something on the chat. Let's check that. So cholesterol level. Okay, now LDL cholesterol normal range. Okay, this says that a normal is to be less than 100 milligram, and then which means that, okay, optimal, near, borderline. Okay, let's just pick one. Are we together? For the sake of this class, let's say we want to use less than 100 to be normal. Or let's say, okay, let's do it this way. 100 to 159, normal. Then 160 and above, high. Is that okay? This is just for the sake of this class. That doesn't mean that is the benchmark. For the sake of this class, anything less than 159 is normal. Whatever it is above 160 is abnormal. So let's just use that to, in a way to categorize. I hope we have something as reasonable. Oh, this is not in that same. I think this must be measured in mole. This is not measured in one moment. Coming. This is measured in milligram. I think that other one is measured in mole. Measured. Okay, now, okay. I've seen something. I hope we are following. Okay, now it says that optimal, if it is less than 2.6, if it is greater than 2.6, it is above optimal. But I'm interested in 2. So I will just use from 2.6 to 3.4 as normal. And then if it is greater than, okay, 4.1 as normal. If it is greater than 4. I can copy and paste this. I will say you try this on your own later. Let me put it on the chat. Where is the chat? So you can use this to categorize later. I hope it's well pasted. Okay, so let me just use this. I just want to pick it into 2 for the sake of this class to save time. So I'll be using 2.6 to 4.1 for normal. Whatever is more than 4.1 as I. Is that okay? Okay, so transform. We code into different variables. So I pick this. Let me return this. So the name I want to call it, a moment. So the name I want to call it coded. Same thing. Change, old new values. So don't forget, each time you open it, all the old details will still be there. You might just have to remove, click on it, remove, remove. Okay, so as I said earlier, I'll be using from 0 range, from 0 through the borderline is 4.1, through 4.1 to be normal. Please don't forget 0 through 4.1. Then let me make it 0, add. and I think it's in 2 decimal places. Let me remove, let me edit this. 4.10. Let me use 4.11 since it's in 2 decimal places. So I've added, let me just remove this. Then range 4.12. Let's just do range to the highest, please. Range to the highest, 4.12, then assign 1, then add. Continue. So, okay, let me close the chart. That has been created. Let me close this again. Then you come here. You can see the new variable. So you still leave it as this. So you come to the values. Don't forget we use 0 to 4.11. Or let me just click 0 to be normal. Don't forget, because we said 0 to 4.11 is normal. Then you can just come here and we use 1 for it. Do we understand this part? Oh, I'll still create time for questions soon. So I have that. Let me just do descriptive. Analyze, descriptive. Frequencies. You remove this, remove it. Then we have cholesterol. Then you click OK. Oh, I clicked the previous cholesterol. My bad. I didn't click the one that has been recorded. Sorry, please. Frequencies. Remove this. Put this. The recorded one. Then I press OK. Can you see? It has, from a continuous variable, that has been turned to a categorical variable. Now, those with normal cholesterol level, they are 55.1%. And then those ones that have high cholesterol level are 44.9%, which means 132 of the respondents have a normal cholesterol level, while 140 of them have a high. In the next class, I will try and bring height and weight in a way we can compute BMI. But I will just try and play around it so that we can see. You can still transform, then compute variable. Now, what do we use compute variable for? Just like we have in the normal arithmetic, just say, for instance, you want to add 2 or more variables. You want to divide one variable from the other one. Let's say, for instance, now, BMI. How do you generate BMI? You can check. Let's check on Chrome. Because BMI is generated from height and weight. How do I generate BMI? See, your weight over your height square. Or, which means you divide your weight by height squared. That is weight divided by height times height. I will try and, okay, let's do it this way. Let's try and populate something. Is that fine? Let's create another variable called height. Then I hope we'll not be generating abnormal stuff today. Wait, let it be in decimal. So let's go to the variable. Let's say height 1.76, 1.76, 1.80, 1.5, 1.9. Wait, let me come here. This is in okay, 1.7 if it's in meter. Okay, so let me just create for just few. 1.5, 1.9, 2.0 if possible, 1.8. So let's say the weight, let's say 65, 70, 69.2, 3, 66.5, 110.2, 120, 89.0, 60.5. Okay, 60.0. Okay, can somebody remind me what's the formula for generating BMI again? Drop it in the chat box.
Weight over height squared. Weight over height times height.
Oh yeah.
So we transform, compute variable. So the name of the variable, come in please. Name of the variable you want to compute is, let's say we want to use this weight. If you notice, you click on it and then the height. Those are the two variables you're interested in. So weight times height, right? Isn't it?
Weight
Divided by,
divided
over
by
height
height square.
okay, weight divided by height squared. Okay. So
Yeah.
let me just control x height times height, isn't it? Are we
Yes.
together? So we call it BMI.
Yes.
So these are functions you can use. We have plus, the addition, even the numeric. If it's just numbers you want to create, you can play around it. You have the random numbers, you have strings. So let's press OK. We have executed it. Let's check. See BMI. Is this BMI normal like this? We have 65, 70, and all. Now,
No, sir.
let's say we are just playing around this, right? So categorization for BMI the other time is what? When we
I
check
think the
Chrome.
formula is wrong.
The formula we use is wrong.
Like dividing height and then multiplying by height, you are canceling out the height. Henceforth, we have only weight. Do you get what I'm saying, sir? It's all raising to power 2.
Okay, I can use, I could have just put it in a bracket, actually.
Yes.
Coming. 1 hour, okay. Let me check again. Thanks for that, for calling my attention to that. Analyze, transform, compute variable. Okay, still there. So I could have just put this in a bracket. I think that settles it, right? Let's check if you still have the same thing.
Yes, it does.
Okay, so I think we have a good result now. Have you seen it?
Yes, sir.
So what do? Let's go to Chrome again. Some of these things you can have it. How do you categorize? Or you can ask your AI. Categorize BMI. Okay. Show more. So for our underweight, what do we have? Less than 18.5. So let's go and try this out. Let me Control C. Let me paste it in the chat box. And you can also use the method of height square instead of just multiplying height by height and putting it in a bracket. So this says for underweight, we have, let me put this here. So you transform again, isn't it? Recode into different variables. So we want to recode our BMI. Let's bring this here. Let's bring this here. I hope you are following, please.
Yes, sir.
Are we following? BMI.
Yes, sir.
The funnest part is that for a particular variable, you can have more than 5 categories, depending on the kind of study you are doing. Because there are sometimes that the normal nomenclature does not apply. Example, maybe when you are dealing with stroke patients and all too. Some of them has that, because of the age and some other things, may have to put some of those things into consideration. So we are doing range. Let's do from lowest to 18.5, isn't it? Then we assign, okay, let's remove all of this first. Remove. Range to lowest. Lowest true value, so 18.5. That means from 0 to 18.5. Assign 0. Add. Then the second one says between 18.5 to 24.9. That is range. So that will be 18 Oh, BMI less than 18. I need to correct this. No one noticed that. It's meant to be 18.49, isn't it? 18.5 to 24.9. This is 1. Add. Now I need to change this because it says BMI less than 18.5. It did not say BMI equals to 18.5. Is that taken? So I will do 18.49. So add. Let me remove this. Okay, now we have BMI 25 to 29.9. So range 25 to 29.9. Then let me make that 2. Add. So range 30 greater. So I can just come here through highest. So from 30 to the highest. Then make that 3. Then add. Then continue. So I can click OK. So you can see it has done that. See BMI categorize. We have just only one underweight. So you can come here, click on it, then assign your values to make life easy. Do you know when you assign values, when you are analyzing, you are not confused. Okay, let me analyze it without assigning values. You will see something. Analyze, descriptive statistics, descriptive, BMI categorized. Click on it. Okay. You will see what we have. Coming. Oh, I've not clicked on that. BMI categorized. Let me see what we have. 1 and 3 alone. Oh, that's why we have that. So let me assign value labels. Let me analyze first descriptive frequencies. Oh, I clicked on the wrong variable. Imagine BMI categorized. Okay, okay. Now what do we have? We have 0, 1, 3. You know, you can't really make meaning from this like this. In a way, you are confused. Now, if you notice this system 304, missing system in the sense that we only try to create 8 variables. We didn't go beyond 8. That's why we have the missing system. So what do you do? Let's assign value label to it, and then you see the difference now. If you notice, there's no 2 because when we converted to the BMI, the categories, none fall under, let's check, where's our chart? None was under incoming. Let me check our chart. None was under normal weight because 0 was underweight, 1 was normal weight, isn't it? 2 was overweight, and then 3 is obesity. So let's add that. Let's assign the value labels. So 0 is. If you feel you are more comfortable with still putting 0 to 18.4 now, you can write it, but I just feel I should just put my normal underweight, add 1, normal, that's the normal weight, then 2. Let me make an example here. 2. What's 2 again? Let's check. Can somebody help me? What is 2? Is that overweight or what?
Overweight.
Overweight. So I can still put, what's the range of overweight? Please assist me.
25
20
to
what?
29.9.
29.9. Is that correct?
Yeah.
I can still put overweight to still take it. I just want us to see how it will look like. Overweight. Add. Can you see that? Then 3. That's 30,
Obesity.
30 to 30 and above, right?
Yeah.
30 and above. So I'll just put obese. Those are obese. So hard. Okay. So let's do the descriptive analyze. Descriptive statistics. Okay, we still have the BMI categorized there. So okay. Okay. Let me analyze again. I should have removed it from the. So let me return it. Okay. So have you noticed? Normal underweight. Normal. You know, I mentioned earlier that no one was, or is he overweight or something? Yes, no one. we could see 30 and above, which is obey. So whichever one or whichever nomenclature you are more comfortable with, feel free to use. You can try to write it as underweight or put the figures or even combine both. Well, one thing is you can export your results. Most times what I do is I export and I put it on Excel, and then I begin to format. But that's not in the scope of what I'm teaching us currently now. So we have that. Now, one thing again is important when you are dealing with transformation, or when you are computing under transformation, like coding. Let's say, for instance, I'm a student from maybe education, or I'm a student from health policy education, and then I'm trying to know the knowledge. Knowledge can be categorized into what? Can I hear our responses? Are we together?
Yes, sir.
Yes, sir.
Knowledge can be categorized into good or a poor knowledge,
Yes, sir.
isn't it? Some can say the knowledge is either low or high. We are going to try out some stuff now. I will just see how well we can go. Let's create it ourselves. I couldn't really share data with us because I have to be careful because of confidentiality. Or better still, maybe I'll create, okay, let's say, for instance, you have a questionnaire that wants to address knowledge. Under the knowledge, how many of us have seen the question? Okay, I shared the questionnaire in the last class. Let me pull out one of the questionnaire. I'm coming. Okay, let me see the questionnaire and share with us. Media. Oh, files. Okay. It's asking me to say what I sent. It is well. All right, downloads. I really wish we have a question that speaks of knowledge here. None speaks about knowledge. Okay, what I'm trying to do in the real sense, I'm coming. Let me pull up another data. Is that fine?
Yes, sir.
Okay, so let me look for another data. A moment, please. Let me pause the recording. If you want to know if a person has high knowledge of sexual violence or a low knowledge, what do you need to do in that sense? You need to sum all these variables. It's called scoring. You sum all of them together. And after summing them, what do? You simply do a descriptive by finding the mean. Now, how do you sum? Let's come here. Transform. Compute variable. This might be a long search because we have quite a number of variables. So we are looking for 114. Okay, we are looking for 109 to 113. I hope these variables are numeric. It's okay. Yeah. Let me see if I can shift. Yeah. Oh my God. I'm trying to click on many at the same time, but so we have these two. We put this here.
Please press Control. Sir,
If I
press
press
Control,
Control, it's clicking on everything. It will click on all the variables. And I'm not interested in all the variables. I don't know if you understand me.
Okay.
So now
I'm thinking if you
I have this, then you add plus. I really wish I'm not just bringing out this data raw. I could have, in a way, fine-tuned the data and then ensure that the names are not as long as this. Oh, sorry, I'm putting it in the wrong place. This is the plus. The plus will be here too. Or the addition sign. 109 plus 110 plus 11 plus 112 plus 113. So let's call it sexual violence score. Score. Are you with me? So you sum it up. Let's press OK. Okay, the name is known than the name of the variable. Oh my God. What do we do? Okay, let's see. The variables I'm using, the names are too long. I really wish. Okay. Should I quickly
Sir, your
record-
first
Yeah. You said? You were saying
the
something?
first plus was hard. I mean, your first plus when you were adding them,
Yeah.
the
I made a
plus
mistake.
was after the at sign. You made a mistake there.
Oh, thank you very much for following. I really appreciate that. Holy, I have to type again. So let me check. I will just do it one after the other now. I won't tell you. 109, right? Then plus 110. I hope this works. But even the names of those variables are quite long. Man. SPSS may not want to take it. 112 plus then 113 plus. Let's see if it will take it. I doubt. Extra support. Oh, fantastic. So we are good to go. So we've created the scoring for that. So let's check it out. Okay, here is it. So the variable will have been created down somewhere. So you can see sexual score. It has added it up. So what you need to do here is, let me even remove the decimal. The sexual score, let's call analyze, descriptive. Let's see descriptives. AI just gives you your mean, give you your sum. I'm interested in my mean practically, which is the average. Continue. So let me come down here, sexual score. So, okay. The mean is, in fact, the mean is very low. The mean is what? 0.60. The maximum score there is 5. The maximum score obtainable there is 5, while the mean is 0.0. That is 0.0. So let's come transform. Recode into different variables. So you click on that particular variable, which is the sexual score. Then let's call it sexual. You know, it is sexual violence. Then categorized. You know, I mentioned earlier that whichever score that is lower than the mean will stand as high or poor knowledge. So you change. So old values. What was our mean again? 0.6. So range 0 to 0. Or anyone that is lower than the mean. Let's use 0.59 since the mean is 0.6 add. Then range 0.6 to highest. Then you put 1. Add. Continue. Okay. So let's go back to our. You see it has been categorized. So to the value label, you have 0, which is poor, maybe poor knowledge of sexual violence. Then you have 1, which is the good knowledge. Then you add, you press OK. Then you remove this scoring, decimal rather. Then you come back here, you do analyze descriptive. If you've noticed, so far so good. We've only been touching the transformation aspects, your data manipulation, and then we have been doing descriptive. Hopefully in our next class, we'll be able to leave this aspect and do some inferential statistics proper. So, okay. You can see, this is the sexual violence score. We can see that 198 participants have poor knowledge of sexual violence, while 50 out of the participants have a good knowledge of sexual violence. Do we get that part?
Yes, sir. Yes,
Oh, I
sir.
think we do. Now, in that case, I can even draw a chart from that. Perhaps. Okay, let me just do analyze. Let me draw a chart from my descriptive. Analyze. Can still do descriptive. Descriptive, explore, cross tabs. Okay, this is not for, okay. Let me just do descriptives, frequencies, charts. Let's use a bar chart, or let's see how it will look like on a bar chart. Okay. Okay. Where is my chart? Coming, analyze, descriptive, frequencies, charts, continue. Okay. Let me reset first, analyze. At times, SPSS doesn't reset. So let's try this now. It's still storing the last analysis in its memory. So let's have the charts, bar charts. You can use either the percentages or the frequencies. Continue. Okay. Or is there a reason why it's not displaying? Okay. Okay, you can see how it looks like in the charts. I guess it was loading. If you notice, it has returned so many charts already. Well, one good thing is I don't really like using SPSS for my charts. I rather use Excel or I use other packages, but I think it has a good graphics for pie chart. Let's see how the pie chart will look like. Let's see how the pie chart will look like. Descriptive, frequencies, charts. Oh, I should have put my percentage for the pie chart. Okay. So which one do you prefer between the pie chart and the bar chart? So you could see those that have the good knowledge of sexual violence and those that have the poor knowledge. You can try to edit your charts, set the height, set the width, apply. You can see that it has reduced in size. You can increase it, apply. You can do all sorts of things with your chart here. As you deem fit, edit, reset. You want to change, undo, you want to copy your chart, you can copy it. Elements, you can do all sorts of stuff, the data label mode. Okay, I think don't let me bombard us with too much information now. So let me see something again here, analyze, descriptive. Okay, I create on frequency instead. Descriptive, frequencies, our chart, percentages, continue, format, compare. So if when you are doing your frequencies, you can check different formats. If you wanted to present the table in ascending or descending order, or you want to organize your output by variables, you can play around all of those things. This style has to do with the way you want your table to be. You can decide to add, see, all applicable, you add, but let me delete. I'm not interested in that. You can just play with it at your Bootstrap. This speaks more of a statistical stuff. Maybe when we proceed to some higher aspect of analysis, then, or let me say advanced, not so advanced, just a little bit of stuff here and there. Now, we've done that. I mentioned when we started in our first class that you can easily use syntax when you must have done all the necessary clicking, what you can do is just you can press paste. What it has done is it brought me to my syntax. I will try that again. Let me close it. Don't let me confuse us. No. Let's say, okay, let's say I want to do descriptive, analyze, descriptive statistics, frequencies. Let me say I click on how old were you, if polygamous, type of marriage. Okay, let me remove charts. I'm not interested in charts this time around. After clicking all that I need to, instead of just pressing OK to display the result, I can press paste. It will open a different editor called the syntax IBM SPSS statistics syntax editor. What this helps you to do is that, let's say for instance, you must have done all your press and click, you click, and then after 2 years, you need to reproduce the analysis you did. You can't, because you just did press and click. But if you use the syntax, you can see what the syntax will do. You can just click on this. You play it. Really, I played it. It gave me my results. Let me go back to some of the analysis I've done, and I will just go and copy those syntax too. Okay, let's say for instance, frequencies. I can copy this. It doesn't want me to copy it. Paste after. I think it has pasted that too. It's not. But one thing I do is that I can just export it to Word, and then I'll copy all those syntax. Style output. I can export it, maybe to whatever I want to export it to. I'll copy those syntax if I'm interested in it, and then I'll paste, and then I will run it. It allows me to run my analysis. Okay, so let's try another descriptive. Frequencies. Okay, let's do this. Click as many variables as possible. Just click paste. Come to your syntax output. You will find it there. See, it's already there. So what you just need to do is just to press. You can click on it and then press display. It will run the analysis. Can you see? I use a pie chart to represent this. So that's just the beauty of this. I would have loved to, in a way, go into inferential statistics tonight, but I feel I will be bombarding us with too many informations, and I want us to, in a way, process this and digest some of these things. But before we call it a day, I would also like to show us something, and then that will lead us into the next class. On this analysis or the analyze button, you can, here you can compare and sort. Okay, then let me go here yet. Let's come here. Let's say on this analysis, you have power analysis. You want to do means, proportion, correlation, regression. You have your reports, the code book. This is all your variables, statistics and all. Then let's say, for instance, you want to do regression. This is your regression. Depending on the type of regression analysis you want to do. And some of those things will be what we will speak to in our next class. And I hope I'll be able to get you a data that you can work with so that it can speak well into it. If you want to do t-test, it's compare means you come to. Compare means it's already showing the different types of the t-tests you might be interested in. If you want to do also a correlation, you can come to correlate bivariates. And then you click here. Then generalized linear model, it's more a kind of advanced statistical analysis. It speaks more of the different types of models, be it the logistics regression, the probit, the binomial, the Poisson, different types. But I mean, maybe we'll take it a little step by step, and then hopefully we get there. But if we can't, I will have taught us the basics that can, in a way, help you to do some of those things, on your own, and then at your own leisure. I think for now, let me give room for questions. Let me give room for questions. I have another thing to do in the next few minutes. So I'll give room for questions, and then in the next class, I will have prepared a comprehensive data. If possible, if I can't, I will share the video, and then we can apply whatever we do to whatever data you have. at hand. Is that taken? Are we
It's fine.
together?
Yes, sir,
Okay, so do
please.
you have questions? I'm with you.
Yeah, thank you, Mr. Anshion, for this rare privilege given to us. But my own question is the one I first asked when this training started. I said, this SPSS that we have, is the license a renewal one, or this one is forever?
Well, you know, SPSS is not free, right? Maybe let me stop recording first.
I know.
Always, we should always write copy our how did you put it, something on the syntax. I don't know, just to save for future purposes so that we will not lose the code in case if we want to change something. Is that advisable for every analysis we are running? Should in case
You
if you
save
want
your
to change
syntax, right?
something? Yes, should in case if you want to
I
change
think
it.
it is actually, because if you don't have syntax and then there are issues, you have to start your analysis from the beginning in a way. I wouldn't know if you understand me, sir.
Yes, I'm following.
But let's say, for instance, you've computed a result, and then unfortunately, the Word document crashed. What do? You start your analysis from the beginning again, and then you start putting back in your Word document, isn't it? But if you have the syntax, all you just is just to run. The only stress we have to do is just to put from SPSS into the Word. That's all. I don't know if I was able to answer that question.
Yes, I understand. But at what level should we start using syntax? Because I'm sure there are
Anybody can
some.
start using its syntax.
No,
There's no
no.
problem.
What I'm saying is that there are some basic analysis you might do that might not require you to be copying the syntax. And for example, you want to do mean, maybe you are starting your analysis from mean, maybe you are doing mode. Do you need to start copying from, or when you get to maybe when you are compressing different variables together and you are doing some maybe complex manipulation, maybe that's when you should start saving your syntax, so that in case you want to tweak something or do something. So I don't know, is it advisable you start from the basic level, probably when we start computing the data from stats, so that I don't know how cumbersome that syntax can be. I don't know.
Yeah, I get you, but me, I would say that it depends on what you're interested in doing. You know, you are the one in charge. It's your analysis. But I would say you can start from the beginning of the analysis to the very end. It doesn't subtract from you, rather it adds to you in case anything happens. I don't know if you understand that.
All right, I
What you are
get.
just doing in the syntax is that you are just pasting it. It's not like you have to go and do anything special. It's just the thing that you are clicking and dropping, that you are pasting on the syntax output or editor. That's just it. All right. Any other question? Okay. Can we have? Yeah, sure. I will do well to send it earlier.
All right,
Okay,
how to edit, or where is editable, so we can know where and where to work on.
Okay, all right. Someone raised his hand. Oh, I guess.
Yes, sir.
All right, sir.
Good evening. Thank you for your time. And I guess I started, yeah, we started together. Can you hear me, please?
Yes, loud and clear.
Okay, so I know we started together, but at some point, I was trying to carry the phone to start too. My concern is about, I know probably as we journey through this class, those concerns would be actually solved. The aspect when we want to know what type of analysis we want to carry out. Like we're talking about t-test, we're talking about some of those terms are actually new. So is there a way we can have, might not be comprehensive because if we can't compare what someone has been doing for years with just an online class like this. So is there we would know, okay, for this type of analysis, this type of data, this is a type of analysis that will be needed. We're talking about regression. I heard it to sound this somewhere in my head, probably because it's a computer word. Something somewhere in my head. So I don't know where and when are those stuffs applicable? If there's a way we can, okay, let me not say we are, probably some of us here are already statisticians, probably some of them are into data analysis before, unlike me that I'm a newbie in this field. So if there's a way we can know what is what and those analyses that at least I followed while you were running those analysis, recoding them, giving them 0 and 1. You get, I understand that part perfect. So when do we do that? Then there was this analysis you did this last one you did, talking about sexual aware, I don't know, sexual stuff.
Violence, that's the categorization.
Yeah. Yeah. So I noticed that while I perused the whole table, I saw that it was like the sentence was just copied directly. I think you're getting it. Like it was so jam-packed. Is that how it's supposed to be? You know, people are coming, are new to this stuff. Is that how it's supposed to be, or it just happens to be like that? I don't know. So probably if there's a way we can actually pinpoint these things. But when you want to do something like this, so this is the type of analysis you do. When you want to do something like this, so basically, I just hope I'm not, I know I'm not using the right term as far as data analysis is concerned, but I just hope you get my point. Thank you.
All right. Okay. Thank you so much for that question, please. Okay. Practically, let me start from when and which type of analysis to do. Before we go further, I will try in a way to explain when to use a particular analysis. Now, practically, before one delve or try to do any analysis, you must have objectives. Objectives in the sense that why do you want to do this analysis? What do you want to achieve? Why are you interested in this analysis? So most times the objectives will determine the type of analysis you do, and then the variables you have. You know, I tried taking us through the types of variables and all. So some of these things will be what we will look into before we start the inferential part of the analysis proper. But the variables you have will determine the type of analysis you will do, and the objectives you have to will determine the type of analysis you will carry out. So two things: objectives and the type of variables. They will determine the type of analysis we have. And then secondly, you mentioned about what I was trying to do the scoring. Well, that's a data extracted from COBOL collect. So it's the way the data was named, or the way the variable were named. So that's why it looks like it's quite long, and then it looks like it's jam-packed. So I just pulled that out from some of the things I've done, and then I felt, okay, let me just use that to play around that and see how well that will look. So that's just that on that. So thank you. I don't know if I was able to do justice to your question.
Yeah, I understand. Thank you very much.
Okay, do we have any other question? Good evening, or do we call it a day?
Thank you so much for the detailed explanation.
Welcome. Okay. Is there any other question? Do we call it a day? All right. Okay. So I think we can all have a vision-filled night. Do enjoy. Okay, tomorrow is Sunday, so do well to go to church and take good care of yourself. So see you next week. Next week class might be longer than this because I really want us to go far. And then so that we can, in a way, start working ourselves. And I want to admonish you, start working around with data. pick up the data, just play around it. You know, you learn more when you practice. That's just the real truth. So, all right. Thank you so much. You have a vision field night. Bye.
Bye.
Sorry, good evening, sir. Can we have web where we can get this data so that we will not be disturbing you?
This particular one or
No,
any data?
not this one. Where you said we should be working so that we can, at least we will try to lay our hands on
Okay, you can check.
questionnaires.
You can just check MBS, Nigeria Bureau of Statistics.
MBS,
check-
okay, that's good, sir. Can you
can
drop
check-
them on the line on our WhatsApp, sir, so that we will not be disturbing you?
All right, it's okay. So
Thank
there are
you so much,
different sites. You can get different data. It depends on the type of data one is interested in. So you
Okay,
can
sir.
just do what to do a reminder, and then I can compile the list of some of the websites.
Very good. Thank you, sir.
Thank you so much. Thank you too.
Good night, sir.
Good night.
So I want to suggest something. I'm so
Okay, I'm
sorry.
listening.
So I'm just thinking of if you can maybe give us tasks